Hello and a very good evening to one and all present here, and welcome to this session on factors. This is going to be the first session that we're going to handle in the model number system. Okay, and number system as a whole model, if you see, is very important in the point of the CAT paper as well. Okay, around 3 to 4 questions on a minimum basis will come on this particular module. Okay, so first looking at the first major and the most important topic, that's going to be factors. First of all, let's try to understand what is a factor. So a factor is any number x that will completely divide a number n without giving any remainder, or simply the remainder should be 0. So in that case, I can say that x is going to be a factor of the number n. Okay, now let us also get to know as to what we are going to do in this particular session. See, most of the questions that come in the CAT paper are based on the number of factors, the number of factors of n, the number of odd factors of n, and the number of factors of n which are multiples of 100. So these kinds of questions are quite redundant in the paper, right? So we are going to deal mostly with the questions based on the number of factors. So for example, of taking a factor and figuring out the number of factors of any particular number n. Let's take a few examples here. Now let's take small numbers so that we are not confused too much. Okay, we don't get too many factors and all here. So let's take small numbers and then proceed with it first of all. So if you look at the number of factors of 4, I know that 4 has a factor of 1, 2 and 4. So there are a total of 3 factors. For 6, the factors are 1, 2, 3 and 6. There are 4 factors. For 7, 1 and 7. So there are 2 factors. And for 100, 1, 2, 4, 5, 10, 20, 50, 25 and 100. So there are going to be a total of 9 factors here. Now from here, one more thing that you can see is, look at the numbers like 7 which are prime numbers. Okay, let's take another prime number. The factors of 5 are going to be 1 and 5. Now let's take another 11. The factors are going to be 1 and 11. So if you take any prime number, you will have only 2 distinct factors. That is 1 and the number itself. Okay, and always for any number, 1 and the number itself, 1 and the number itself are definitely going to be the factors. Okay, so for any prime numbers exclusively, you can also say that a prime number would be a number which has exactly 2 distinct factors, and the factors will be 1 and the number itself. Okay, so if x is going to be a prime number, then the factors of x will be 1 and x. That's it. Now if I give you larger numbers like 1000, 1243, or say for example I go for even larger numbers, 20,564. So when I have these kinds of numbers, will you be able to figure out the number of factors in this manual method? And that also in the given prescribed time of 1 to 2 minutes in the exam? Definitely no, right? And even if you try to, the manual method is always prone to a lot of silly errors. So what we can do is we can try using a prime factorization method here. So let's see how prime factorization works in figuring out the number of factors of any particular number. Right. Now look at 16. Okay, 16 I can write it as 2 power 4. Correct? Now the factors of 16 are nothing but 1 is 2 power 0, 2 is 2 power 1, 4 is 2 power 2, and 8 is 2 cube, and 16 is going to be 2 to the power 4. So you see that there are 5 factors. And how do these factors come? They are all in the format of 2 power n, where n can be at most 4. Okay, and n can be only whole numbers. Okay, if n becomes negative, then they become fractions. Okay, so they become the inverse 1 by n all. So we have to avoid that. So look at these factors, the factors of this number. For the value of n, it ranges from 0 to 4. That means if any number is in the format 2 to the power n, okay, the factors of this number will range from 2 power 0 up to 2 power n. So how many factors will be there? You can say, you can always say that from 1 to n there will be n factors, and including the 0 there will be 1 extra factor. So there will be a total of n plus 1 factors. Correct. So what I can also say is any number now. Okay, I can just generalize it. Any number in the format a to the power n, where a is going to be a prime number, a to the power n. This will have definitely n plus 1 factors. That's it. Okay, now what if the number is more complex? What if it is not only the format a power n? If it's in the format a power n into b power m into c power z and so on. So what do we do with those kinds of numbers? So let's have a look at this. So I've just taken an example of a number here, and that number is nothing but 2 to the power 4 into 5 to the power 5 into 7 to the power 3. Okay, and just for our convenience, I have written down the same number in the format 2 power a into 5 power b into 7 power c. So we'll be figuring out the values of a, b, c separately. Now, see. First of all, let us just discuss a few things first of all. Okay, so if n is equal to 2 power 4 into 5 power 5 into 7 cube, can I say 2 power 0 is a factor of n? Obviously, 2 power 0 is 1, that is going to be a factor of any number, right? Can I say 2 power 1 is going to be a factor of n? Yes, 2 power 1 is there, so 2 power n can also be a factor of n. Now, can I say 2 power 6 can be a factor of n? Obviously, no, because the maximum power of 2 here is going to be 4. Am I right? So, the factors of n here, okay, especially in the powers of 2, can go from 2 power 0 up to 2 power 4. That means the value of a can take from 0 to 4. So 0 to 4, how many values are there? There are 5 different values. So a can take 5 different values, right? Now, let's go to 5. Okay, now 5 power 0, can it be a factor of n? Yes. 5 power 1? Yes. 5 power 2? Yes. But 5 power 7? 5 power 8? No. The highest power of 5 here is going to be 5. So, it can range only from 5 power 0 to 5 power 5. So, how many factors are available from here? 0 to 5? There are 6 factors that are available here. Okay. And similarly for 7 cube. Okay. Can I take 7 power 0 as a factor of n? Yes, that's available. 7 power 1, yes. 7 power 2, yes. 7 cube, that is also yes. But 7 power 4, no. Because the highest power of 7 here is going to be 3. So here, 7 power 3. Okay, the factors in terms of 7 power n. Okay, for this capital N, this number. Okay, I can say the factors will range from 7 power 0 to 7 power 3. So, how many factors are available? There are 4 factors available. If you see here, na, the value of A can go from 0 to 4, so 5 values it can take. The value of B can take 0 to 5, so it can take 6 values. The value of C can actually take 0 to 3, so it can take 4 values. Okay, now also think about this. Can a number in the format, okay, 2 power 2 into 5 power 1 be a factor of n? Possible, right? So combinations are also possible. Okay. So out of all these factors that we separately got, now combinations of those are also possible. So what I can now say is the total number of factors of this particular number n is going to be nothing but A gets 5 values, B has 6 values, C has 4 values. So total number of factors will be 5 into 6 into 4. That's it. Okay. Now, let's go to the second thing. Figuring out the number of odd factors. Figuring out how many odd factors are there. Now, what is an odd number? A number which is not divisible by a 2. So, the number should not be divisible by 2 means there should be no 2's inside. Okay. But can I take 2 power 0? Yes, I can take 2 power 0 because 2 power 0 is 1. 1 into any odd number gives you an odd number only. Now, only see, a even number should be multiplied minimum with 2 power 1. Okay, so multiplying 2 power 0 doesn't ensure that the number becomes an even number. So A can take only one value. Okay, A 2 powers. Okay, A can take only one value and that is going to be 0. It can take only one value. Now, is there any constraint on 5s? Is there any constraint on the powers of 5? No. And is there any constraint on the powers of 7? No. So I can say that here 5. Okay, here 5 powers. B can take values from 0 to 5, 6 values. Similarly, C can take from 0 to 3. That's going to be a total of 4 values. So the number of odd factors of this number will be 1 into 6 into 4. Okay, so I'm not simplifying it, I'm just helping you how to do it. Okay, simplification is anyone's game, right? Anyone can do that, so I'm just leaving it there. If you want, you can simplify and keep it. Next thing, okay, from here, figuring out the number of even factors. Now we saw the number of odd factors. Odd factors means it was not a multiple of 2. So here even factors means the minimum power of 2 should be 1. So the number should be in the format 2 power 1 into a. Now a can be anything. It could be odd or even. There's no constraint on the remaining. But all I know is the minimum power of 2 should be 1. That is the one and only constraint. So a, which is nothing but the power of 2. Okay, so a can take values only from 1 to 4. It can, see, 2 power 1 into a is going to be a multiple of 2. 2 square into a is also a multiple of 2 and so on. So minimum power of 2 should be 1. That's it. So a can take values from 1 to 4. So 4 values are possible. But there is no constraint on the values of on the powers of 5 and 7. Okay, the only constraint was the minimum power of 2 should have been 1. So B can take 0 to 5, 6 particular values, and C can take 0 to 3, 4 values. So the number of even factors of this number will be 4 into 6 into 4. Okay, so far so easy. Now if you want to also check whether you are on the right track or not, okay, if you add the total number of odd factors plus the number of even factors, you will be getting the total number of factors. You will be getting the total number of factors, which is nothing but 5 into 6 into 4. It's going to be nothing but 5 into 6 into 4. Okay, if you add both, you'll have to get this particular value. Okay, so now let's go to the next one. Now the number of factors which are multiples of 4. So before this we saw the number of even factors. The number of even factors means the number of factors which are multiples of 2. So multiples of 2 means the only constraint was the minimum power of 2 should be 1. Now similarly, if I have to go with the number of factors which are multiples of 4, 4 is nothing but 2 square. So the number should be in the format 2 square into a. That means the minimum power of 2 should be 2. That's the only constraint. So what are the values that are possible for a? A can take the minimum value 2. So 2, 3 and 4. There are 3 values that are possible. But there is no constraint on the powers of 5 and the powers of 7. So B can take 0 to 5, 6 values, and C can take 0 to 3, 4 values. So the number of factors which are multiples of 4 will be nothing but 3 into 6 into 4. Right. Now same way we'll have to go for the number of factors which are multiples of 5. So I'm just going to give you 30 seconds here. Please do that. Number of factors which are multiples of 5. Just 30 seconds you do that, and then we'll start the discussion. Okay, so number of factors which are multiples of 5. Multiples of 5 means it should be in the format 5 to the power 1 into a. Okay, so the constraint is the minimum power of 5 should be 1. A multiple of 5 means the minimum power of 5 should be 1. There is no constraint on a. A can be anything. So the only constraint is the minimum power of 5 should be 1. So 5 is here, right? So 5 is here means I can say that B, the minimum value of B has to be 1. So B can take 1, 2, 3, 4 and 5. So B can take 5 values. There is no constraint on the powers of 2, no constraint on the power of 7. So A can take from 0 to 4, 5 values it can take, and C can take 0 to 3, 4 values. So total number of factors which are multiples of 5 will be nothing but 5 into 5 into 4. This is it. And then going on to the number of factors which are multiples of 20. Write it similarly. Now you have found out separately the number of factors which are multiples of 4, multiples of 5. Now you will have to find out the number of factors which are multiples of 20, which is nothing but 4 into 5. Okay, try it out. 30 seconds for this again. Okay, so the number of factors which are multiples of 20. 20 is nothing but 2 square into 5 power 1. So multiples of this number will be in the format 2 square into 5 power 1 into a. So there is no constraint on a. The minimum power of 2 should have been 2 and the minimum power of 5 should have been 1. That are the only constraints. So a's minimum value has to be 2. So a can take only the values 2, 3 and 4. So only 3 values are possible. So for the powers of 5, the minimum power of 5 should have been 1. So B can take values only from 1 to 5. There are 5 particular values for that. Okay. And there's no constraint on the remaining. On the powers of 7, there's no constraints. So the powers of 7 can go from 0 to 3. So total of 4 values they can take. So the number of factors which are multiples of 20 will be 3 into 5 into 4. That's all. Okay. Now going on to the number of factors which are perfect squares. Now before doing this, let me tell you, how does a perfect square look? So I have a perfect square, 2 square is there. Okay, I also have 2 power 0 is also going to be a perfect square, right? 2 power 0. I have 2 power 6, okay, which is nothing but 2 cube whole square. Then I have 2 power 4 whole square, which is 2 power 8 and so on. So if you look at the powers of any kind of a perfect square, you will see that the powers of a perfect square are going to be even. Okay, so the powers of a perfect square are all going to be even. Now, what are the possible values of a? It should be even, right? To maintain this as a perfect square, it should all be even. So it can take 0. Okay, a can take 0, 2 and 4. So 0, 2 and 4. There are only 3 values that are possible. Okay, for the powers of 5, for b, I can take 0, 2 and 4 again. So 0, 2 and 4 again. So again 3 values are possible. And going on to the powers of 7. 7 for C, I can say that the values that are possible are only 0 and 2. So 2 values are possible. So the number of factors which are perfect squares will be nothing but 3 into 3 into 2. So similarly, I give you 30 seconds. Please do try out for the number of factors which are going to be perfect cubes. For perfect cubes, first of all, identify what kind of power should be there. Okay, then after that, go down to it. 30 seconds for this. Right. The number of factors are perfect squares. Now look at perfect cubes. Look at perfect cubes. I can say 2 power 0 is a cube. Okay. 1 is always a cube. It's a perfect square. It's also a perfect cube. And then I have 2 cube. Then I have 2 square whole cube, which is 2 power 6. I have 2 cube whole cube, which is 2 power 9. So it's either 0 or a multiple of 3. The powers have to be multiples of 3. Okay, so that's the case that I have to take for a. What are the possible values of a? Remember that it has to be 0 or a multiple of 3. Okay, so for a, I can take 0 and 3 are possible. So there are a total of 2 values that are possible for a. And for b, the powers of 5 also 0 and 3 are only possible. Again, 2 are possible. Okay, and for the powers of 7, again 0 and 3 are possible. So 2 values are possible. The total number of factors which are going to be perfect cubes will be nothing but 2 into 2 into 2. That's it. 8 is going to be the answer. Now, 30 seconds for you. Please figure out the number of factors which are multiples of 1 to 25. Please figure out the number of factors which are multiples of 1 to 25. Now, understand what is 1 to 25 and then go ahead. Number of factors which are multiples of 1 to 25. By now you should have done it. So number of factors which are multiples of 1 to 25. First of all, understand 1 to 25. What is this number? What is 1 to 25? This number is nothing but 35 whole square. 35 whole square is going to be nothing but 1 to 25. Right. Now 35 whole square can also be written as 5 square into 7 square. Okay, that means the number should be a multiple of 1 to 25 means the number should be a multiple of 5 square into 7 square. So the number should be in the format 5 square into 7 square into a, where there's no constraint on a. Okay, the minimum power of 5 should be 2 and the minimum power of 7 should be 2. That is the only constraint. So on the powers of 2, there's no constraint. So a can take values from 0 to 4. Okay, so all the 5 values it can take, and b can take b is nothing but the powers of 5. So minimum power should be 2. So 2, 3, 4 and 5. Okay, 2, 3, 4 and 5, only 4 values are possible. For the powers of 7, c, okay, I can say that the minimum power again should have been 2. That means you can take 7 power 2 and 7 power 3. So only 2 values are possible. So the total number of factors which are multiples of 1 to 25 are nothing but 5 into 4 into 2, which is going to be exactly 40 factors that are multiples of 1225. Okay, so by the end of this, we should be able to figure out the number of factors given under whatever constraint or whatever condition is given. We should be able to figure out the number of factors of any particular number. Okay, apart from this, there's again one more certain thing that is quite important. Okay, and that is the number of ways in which n can be written as a product of two numbers. So let us just go with examples first of all. See, first what I'm going to do is I'm going to take a perfect square. Okay, I'm going to take a perfect square. 100 is going to be a perfect square. And if you look at a perfect square, now a perfect square is always going to be in the format a to the power a multiple of 2. Okay, so you see that the number of factors of this number will be nothing but 2x plus 1, which is nothing but going to be a odd number. So always the number of factors for a perfect square is always going to be odd. Okay, and the perfect square's exact square root will come exactly in the middle. As many factors are below it, that many factors will be above it as well. Okay, now let's come to the question. What are the number of ways in which n can be written as a product of two numbers? So first, this 100. How can we write as a product of two numbers? I can write it as 1 into 100, 2 into 50, 4 into 25, 5 into 20, and then finally 10 into 10. So there are 1 into 100, 2 into 50, 4 into 25, 5 into 20, and 10 into 10. There are going to be a total of 5 ways. Okay, how did this happen? In case of perfect squares, I know that a perfect square, this perfect square will have n number of factors. And this n is going to be n number of factors it's going to have, and this n is going to be an odd number. Okay, why? Because this side equal number of terms are there, this side equal number of terms are there, and they are pairing up with each other. And the middle term is going to be the square root. Okay, so let me just remove this one term. Let me remove that one term. So as many terms are this side, that many terms are this side, so there will be even number of terms now, there will be even number of factors, and I know that they will exactly form pairs. So they'll be forming exact number of pairs, so divide by 2. So 8 factors are there, means they'll be forming 4 pairs, correct? But remember that the square root of n into square root of n is also going to be a way in which you can write this n as a product of two numbers. 10 into 10 is also 100. So you just have to include that one particular way also. So if at all you know that the number given n is going to be a perfect square, then the number of ways in which you can be written as a product of two numbers is n minus 1 divided by 2 plus 1 ways. Okay, now let's take an example of a number which is not a perfect square. So take this number 20 or whatever. You will see that numbers which are not perfect squares will always have even number of factors. Okay, and if you divide them into two equal halves, the first set will form pairs with the second set. Like 1 into 20 is going to be 20, 2 into 10, and then 4 into 5. So if there are n number of factors, okay, I know that definitely it's going to be even. So there'll be exactly half the number of pairs. Okay, so if there are 6 terms, then the number of ways in which they can be written as a that number n can be written as a product of its factors is nothing but 6 divided by 2, which is 3 ways. Here the 3 ways are 1 into 20, 2 into 10, and then 4 into 5. That's it. So these two things, if you remember, then that is going to be much more easier, right? So with this much of knowledge, okay, let us now enter into the questions. So I have not kept too many questions, Mary. I've just kept a maximum of 5 questions here, okay, so that you just practice and get used to this particular concept. So let us go ahead, okay, and please try this first question. And I'm going to give you a maximum of 2 minutes for this. Go ahead. Please try to understand the question very carefully, okay. There are 3 options there, and then choose which of these are true. There could be multiple answers which are right, okay, or there could be options which are not at all right as well, okay. Neither A, neither B, neither C also could be the answer. It could also be all the 3 or any 2 or any one. Do this. 30 seconds more. Please put your answers on the chat box. Okay, so let's have a look at this particular question. See, a number n has 28 factors. A number n has 28 factors. Which of these are true? So if a number has 28 factors, okay, so can I say that the number could have been in the format a to the power 27? If the number is in the format a to the power 27, okay, then I could have said that the number of factors is going to be 27 plus 1, that's going to be 28 factors. Okay, but if I ask you, is this the only possibility? Then no, this is not only the possibility. Now, from each of these, if n is equal to a to the power 27, okay, note that a to the power 27, the power is a multiple of 3. So if the power is a multiple of 3, I can say that the number n is a perfect cube, right? So B holds true. N could be a perfect cube. Now see, this was n could be a perfect cube. So they have just said that there's a possibility. Okay, yes, and possibility is there. But option A says that n is a perfect square. So if n is equal to a to the power 27 is a possibility, right? So perfect squares, what kind of power should they have? They should have even number of powers, right? The power should be a multiple of 2. But in this case, is it a multiple of 2? No, it is not. So n is a perfect square, which has been given as a definite statement, is not true. Okay, now let us go with C. N can have at most of 3 prime factors. Now I haven't gone with the further options here. Okay, so as of now I know that N can have one prime factor, and that prime factor is A. Okay, now this 28, first of all 28 can be written as 1 into 28. Okay, so that is why we wrote that the number could be written as a to the power 27. Okay, now it can also be written as 2 into 14. So can there be a number n which is in the format a power 1 into b to the power 13? So a power 1, okay, then 0 and 1 if I consider, there will be two values that I can take, and from here I can take 14 values from 0 to 13. So 2 into 14, this is also possible, correct? Right. Now, what else is possible? Let us have a look. 3 is not a multiple, but 4 is a multiple. So, can I write it as 4 into 7? Yes. So, n can also be in the format a to the power 3 into b to the power 6. So, here you'll have 4 values and here you'll have 7. So, 4 into 7, a total of 28 factors. Okay. Now, is this the only way that I can split it up? I can also split it as 2 into 7. Correct. Now, if I put this also as 2 into 7, you will get the same thing. So 2 into 2 into 7, which means n could be in the format a power 1 into b power 1 into c power 6. Got it? So a power 1 will have 2 factors, b power 1 will have 2 factors, and c power 6 will have 7 factors. So total number of factors of this n will be 2 into 2 into 7 is going to be 28 factors. Okay, so n could have one prime factor, n could have two prime factors, or n could also have three prime factors. Now you cannot further split it beyond this. So I can say that n can have a utmost of 3 prime factors. That's it, not more than that. Okay, so options B and C both were correct for this particular question. So I hope now if only the number of factors is given to you, you will also be able to figure out what kind of a number it was previously. Okay, so one more question towards end I have kept based on this. So before that, I want you to end the question here. Okay, so please take this question now. It's going to be a very, very simple question. Try to understand and do it. Okay, I'm going to give you a total of 1.5 minutes for this particular question. Find the number of factors of n where n is equal to 5 power 5 into 7 cube into 11 power 7, which are multiples of 25 but not 125. The number of factors which are multiples of 25 but not 125. So please put in your answers on the chat box. Right. So find the number of factors of n which are multiples of 25. 25 is nothing but 5 square. So the number should be in the format 5 square into a, where there's no constraint on a. Okay. But it should not be a multiple of 125. That means it should not be a multiple of 5 cube. Understood? That means this a now should not contain any more 5s. If it contains even a single 5, then the problem will become that this will become 5 cube, which makes it a multiple of 125. So I can say that the power of 5 should remain only as 2. Now the power of 5 cannot be 0, because if I have 5 power 0, then you will not get 25. Okay, I cannot have 5 power 1. So again you will not get a multiple of 25. The power of 5 can be 2, because then we will get a multiple of 25. So it should be in the format 5 cube into a. Okay, but you cannot have the power of 5 to be 3. You can't have the power of 5 to be 4 nor 5. Okay, so there's a constraint on a also, that a should not contain any more 5s. So that means the power of 5 should only be 2. So if I take this as 5 power a into 7 power b into 11 power c. Okay, so let me write it down, okay, so that you can read it properly here. So if I write it in the format 5 power a into 7 power b into 11 power c, okay, then I can say that this value a, okay, this value, let this be x here. So this value a, the only value of a is going to be 2. That means a can take only one particular value. For b, is there any constraint? For b, there's no constraint. So b can take the values from 0 to 3. They can take 4 values. And similarly, there's no constraint for c as well. So c here can take the values from 0 to 7. It can take 8 values. So the total number of factors which are multiples of 25 but not 125 will become nothing but 1 into 4 into 8, which is going to give you a total of 32 numbers, 32 factors. That's it. Okay, so this was one of the simplest questions, my dear. So I just kept this question so that I understand whether you people have understood the real concept behind figuring out the number of factors of any particular number or not. Okay, so this way they may also ask you, okay, figure out the number of factors of a number which are multiples of 100 but not of 1000, okay, which are multiples of 100 but not of 200. So those kinds of values can also be there. Okay, so always be prepared whenever you have extra conditions also there. Okay, so a single condition question is not always bound to come. You can have double conditions or a triple condition question also, and accordingly at that particular moment you should be able to deal with that particular problem, right? Okay, so let's now move ahead to the next one. Okay, so please take 2 minutes for this particular problem, think over it and then do it. Have a closer look at the number. The number is in the format XYZ, XYZ. So think about that number, you will get the clue. And please put your answers on the chat box. 30 seconds more. Okay, so let's go ahead with this particular problem. See, first of all, whenever you get these kinds of numbers, XYZ, XYZ, or any number which is in the format XYZ, XYZ, okay, where XYZ repeats even times. So if XYZ repeats even times. So whenever you have these kinds of questions, remember, take this number XYZ, XYZ and divide it by XYZ. XYZ goes here one time, 0, 0, again one times. So this number is always going to be a multiple of 1001. So I can write this number XYZ, XYZ as 1001 into XYZ. Okay. And 1001 is a very, very special number. And this is nothing but the product of three consecutive prime numbers, which is nothing but 7, 11, and 13. So into XYZ. Okay, so I've completely factorized this number. Now let us see if I have additional information that is given based on this number. So a number XYZ has two factors they have said. So what kind of a number will have two factors? What kind of a number will have only two factors? Exactly. A prime number will have only two factors, and the factors will be 1 and the number itself. 1 and the number itself. Okay, so this is prime factorization of the number. So when I'm prime factorizing this number can be 7 power 1 into 11 power 1 into 13 power 1 into now XYZ becomes a prime number. So XYZ whole power 1. Now just to avoid confusion now, I will just term this as a prime number P. So the number is in the format 7 power 1, 11 power 1 into 13 power 1 into P power 1. Why? Because when we see XYZ as a 3-digit number now, not every time does it strike the student that it's a prime number. Okay, so it may confuse you when you're going forward with the calculations in the exam. So you know that XYZ is a prime number. So you just replace it as P. So this is going to be it. Okay, now P cannot be 7, P cannot be 11, P cannot be 13. Why? Because P is going to be a 3-digit prime number XYZ. Okay, so it cannot be 7, it cannot be 11, it can be 13. So you can't merge it, you have to keep it separate this way. So what will be the total number of factors of this number? Here 7 power 1, 2 factors. From here 2 factors. 13 power 1, 2 factors, and P power 1, 2 factors. Total 2 into 2 into 2 into 2 is 2 power 4. It's going to be a total of 16 factors. So it is option B that satisfied this particular question. Okay, so hope we are now clear with this. Right? Okay, so now I'm just going to pass on another problem for you. Please take your time and do this particular problem. A 2-minute gap for this. Go ahead. Go ahead and put your answers on the chat box if you've got it. The clue here is the sum of the number of factors of n and the number of factors of n square is 34. So the number of factors of n squared, what kind of factors should it have? So that is a major clue here. If you understand that equation, then the question can be easily solved in fraction of seconds. Thirty seconds more. Okay, so number n is less than 150. So from here, let us write down what are the possible values of n. So n could be 1. Okay. When you're talking about the number of factors, you just have to go with the positive values, right? So number is less than 150, so you can go from 1 to 150. Okay. Now the sum of the number of factors of n. The sum of the number of factors of n. So number of factors of n and the number of factors of n square is going to be 34. Now, from here, please tell me, n square is a perfect square, right? So, if it's a perfect square, what kind of factors will it have? Odd or even? You tell me. N square is a perfect square. A perfect square will have odd number of factors, right? Perfect. Now, 34 is an even number. So, odd plus what will give you even number? Obviously, odd. So, if n is having odd number of factors, then damn sure that n also has to be a perfect square. So what are all the perfect squares? You can take 2 square below 150. So 2 square is 4, which is less than 150. 3 square, yes. Okay, I'm writing it in prime factors method because obviously whenever I get any question on factors, I have to go with prime factorization. So it's better when I write down the numbers itself, I write it down this way. Okay, so 2 square, then 3 square, then 4 square. 4 square is nothing but 2 power 4. Then I have 5 square, then 6 square. 6 square is 2 square into 3 square. Okay, and then 7 square. Then 8 square is 2 cube whole square, which is 2 power 6. Then 9 square is 3 square whole square, which is 3 power 4. And then 10 square is going to be 2 square into 5 square. Similarly, I have 11 square, which is 121. And 12 square. 12 square is 2 square whole square, 2 power 4 into 3 square. Okay, so these are the values. Now I can't go beyond 12 square. 12 square ordered is 144. So 13 square is 116, which is greater than 150. So I can't go there. Okay, now I have to choose which of the following can be the values of n. Now look, any number in the format a square, okay, where a is a prime number, definitely will have 3 factors. So I can now take these numbers at a go and I say that if n is in the format a square, then it will have 3 factors. Okay, so n square, that is a square whole square, which is a power 4, will have a total of 5 factors. So the sum of the number of factors of n plus the number of factors of n square is going to be 8 in this case. But they have given that the sum has to be 34. So condition doesn't satisfy. So I can say that none of the numbers in the format a square are going to satisfy this particular thing. The next most common number is in the format 2 to the power 4 or a to the power 4, a prime number to the power 4. So if n is going to be a number in the format a power 4, it will have 5 factors. And n square will be a power 8, which will have 9 factors. So total number of factors is going to be 14. And that also doesn't satisfy. The total number of factors here has to become 34. It doesn't satisfy, so this also goes away. Next, I have in the number in the format 2 power 6. So if n is in the format a number 2 power 6, this will have 7 factors. And n square will be 2 to the power 12, which will have 13 factors. So totally I'll have only 20 factors. So even this doesn't satisfy. So let's go ahead. This is more now. This is common there. Okay. So if the number is in the format a square into b square. Okay, both these numbers are in the format a square into b square. So this will have 3 into 3, a total of 9 factors. And then an n square will be a power 4 into b power 4. This will have 5 into 5, a total of 25 factors. And the total number of factors of n plus the number of factors of n square will be 9 plus 25, which is 34. And this actually satisfies. So this will definitely satisfy. Now one more is left out, a number in the format a to the power 4 into b square. Now let me check whether this number also holds true or not. Okay, I shouldn't leave any stone unturned here. So the number of factors of this a power 4 will be 5 and b square will be 3. So number of factors will be 15. Similarly for n square, you'll have a power 8 into b power 4. So that will have 9 into 5, a total of 45 factors. That gives you a total of 60 factors. So this is way beyond the number of factors that we required. So this is not going to be the answer. So only 2 values, and those 2 values in the format a square into b square satisfied. So the number of possible values of n is going to be nothing but 2. You can take only 2 different values. Okay, hope this question is clear now. Right, let us now go to one more question. Okay, and this question is based upon the number of ways in which a number can be written as a product of 2 of its factors. Please do try this up. I'll give you a total of 2 minutes for this. Go ahead. First of all, factorize 3000 and then after that you move ahead. A minute more to go, and please put your answers on the chat box. You can write down the subdivision A and then the answer, B and then the answer, C and then the answer. Okay, so let's start with this particular question here. See, in how many ways can 3000 be written as a product of 2 even factors, 2 odd factors, and 2 factors, 1 odd and the other even? So first of all, let's go with prime factorizing this number 3000. So 3000 can be written as 3 into 1000. 1000 is nothing but 2 cube into 5 cube. Right? So 2 into 5 is 10. 10 cube is going to be 1000. So 3 into 1000. Okay. Now, in how many ways can it be written as a product of 2 even factors? First thing, an even number should be in the format 2 power 1 into a. Okay, so 2 numbers should be there which are both going to be even. So the minimum power of 2 in both the cases should be 1 to ensure that it is going to be an even number. Okay, so product of these numbers should give you the number n, and n is nothing but 3 into 2 cube into 5 cube. So I can write this number as a into b is equal to 3 power 1 into now 2 power 1 because the 2's have got cancelled, okay, into 5 cube. Now understand that this number has to be written as a product of 2 numbers. So in how many ways can you write this number as a product of 2 factors? First you have to figure out the number of factors of this. The number of factors of this number will be 2 into 4, and that's going to give you a total of how much? 4 into 4, 16 factors. Correct. So if you have even number of factors, in how many ways can you write this number as a product of 2 of its factors? You take 16 and then you divide it by 2. N by 2, that was it, right? So there are only 8 ways. So 8 ways are there in which you can write 3000 as a product of its two even factors. Now, going on with B. In how many ways can 3000 be written as a product of its two odd factors? So, first of all, an odd number into another odd number is definitely going to give you an odd number. Correct. But 3000, is it an odd number or an even number? 3000 is a even number. So, odd into odd can never ever be an even number. So, 3000 can never ever be written as a product of two of its odd factors. So, answer for this is going to be there are 0 ways. And for the previous one, answer was 8 ways. Now, going on with C. Now, two factors, one odd and the other is even. There are two ways in which you can do this. Okay, the first method in which you can do it is, in how many ways can you write a number 3000 as a product of two of its even factors? First is, the total number of ways in which you can write a number as a product of two factors will be nothing but even into even plus odd into odd, the number of ways in which it can be written as a product of two even numbers, plus the number of ways in which it can be written as a product of two odd numbers, plus the number of ways in which it can be written as a product of odd into even, plus the number of ways in which it can be written as a product of even into odd. Now, in the third one, they've asked for these two cases together. The total number of ways in which 3000 can be written as a product of two numbers would be nothing but, this number has to be written as a product of two numbers. So how do you do that? You figure out the number of factors of this, 4 into 4 into 2. And then you divide it by 2. Okay, because it has got even number of factors. So directly n by 2 you do. So this is going to give you a total of 16 ways. Okay, so totally you have 16 ways. Number of ways in which you can write it as a product of two even numbers is 8, which you already figured out in option A. Okay, and the number of ways in which you can write this number as a product of two odd factors is 0, which you have already figured out in B. And let me put this as x. X is what you have to get it. Okay, this was 8. So x, the number of ways in which you can write a number 3000 as a product of two factors, one of which is odd and the other is even, is nothing but 16 minus 8, which is going to be 8. So this is one way. Or the other way in which you could have done it is nothing but, see, you take in, see, 3000 is ultimately going to be an even number. So you have to write this number as a product of one odd number and the other even. So odd, you take any odd multiple of, you take any odd factor of 3000. It definitely has to multiply with the even factor to give this a number. So your job is only to figure out how many odd factors are there of 3000. So if you figure out the number of odd factors of 3000, okay, those will definitely pair up with another even number and give you that number. Or say for example, let me take the number 15, not 15, let me take the number here 36. The factors of 36 are 1 into 36, 36, 2 into 18, then I have 3 into 12, then I have 4 into 9, and then I have finally 6 into 6. The number of ways in which I can write this number 36 as a product of its two factors, one of which is odd and the other is even, is 1 into 36, okay, then 3 into 12, and then I have 4 into 9. So there are only 3 ways, okay. And if you look at it now, there are only 3 odd factors of this number. So if you figure out the number of odd factors of the number, they will definitely pair up with the even number to give you that number, the whole number n, 3000. Okay, so your job here is to figure out the number of ways in which the number of odd factors, not the number of ways in which, the question is the number of ways in which you can write 3000 as a product of its two factors, one or the other is odd. So this can be also rewritten as figure out the number of odd factors of 3000. So to figure out the number of odd factors of 3000, okay, that means it should not be a multiple of 2. So the power of 2 could be only 0. So from here, from the powers of 2, I can take only 0. So only one factor I can take. There's no constraint in the powers of 3. So that's 3 power 1. So 3 power 0, 3 power 1, I can take both. And no constraints on 5 powers also. So 5 power 0 to 5 power 3, there are 4 values. So you will get 24, that is 8 ways. Okay. And this was the same answer you got in the previous case as well. I hope now this one particularly becomes easier for you, right? Now let's go ahead and then try to do this particular question. Okay, so use your brains, my dear. 2 minutes and then finish this off. Okay, go ahead with this. Which is the least number with a total of 18 distinct factors? Check out for all the different possibilities. Okay, the last question here. A minute more. Okay, so let's get into the discussion of this question, Nadia. Enough of time. See, which is the least number with a total of 18 distinct factors? First of all, if a number has 18 distinct factors, okay, I can write this number, okay, 18 as 1 into 18. So the number n could be of the format a to the power 17. So a power 17 will have 18 factors. It can also now be written as 2 into 9. That means the number can also be written as n is equal to a to the power 1 into b to the power 8. The number can also be written as now 3 into 6. So n can be of the format a square into, here this is going to be b to the power 5. Right. Next, I can also write this number 3 into 6. After 3 into 6, it becomes again 9 into 2. No? I can write this number as 3 into 3 into 2. I split this also 3 into 3. I get 3 into 3 into 2 only. Okay. So that means the number can be in the format n is equal to a square into b square into c. Okay. Now I'm worried about the lowest possible value, the least number. Okay, so all these numbers are going to have 18 distinct factors only, but I'm going to figure out which is the least number. So I know that a, b, c here are all going to be prime numbers. So to figure out the least number, now try to put the least value of a, b and c. So the least value here for a is nothing but the number has to be 2 to the power 17. Okay, so this number is around 1024. 2 power 10 is 1024 into 2 to the power 7. Okay, I'm just keeping it as it is. The second case, okay, now a power 1 into b power 8. So b power 8, I'll keep it as 2 to the power 8 and I'll keep it as 3 to the 1. To minimize it, if I had kept here 3 to the power 8, then that would have become a maximum value. So I'm just minimizing it. So putting the minimum prime factor that's available, putting it here. Okay. Now this will be around, yeah, 2 power 8 is going to be, I think, 256, right? 256 into 3. Okay. So obviously this one is lesser, the second one. So I can cancel this off. The second one as of now is lesser. Now going into the next one. Okay, a square into b power 5. So b power 5. So put the least value, least prime value for b here. 2 power 5 and then 3 square. So this is going to be 9 into 32. 9 into 32. This is going to be somewhere around 300 and something. Okay, not even 307, 200 and something. So I can say that again, I can cross this out. This value is comparatively lesser. Now going on to the last one. Okay, a square into b square into c. So take the least possible prime number 2 and for a. Then next one will be 3 square and c power 1, I'll keep it 5. Okay. So 2 square is going to be 4 and 3 square is going to be 9 and 5 power 1. So this is 4 into 9, 36. 36 into 5 is 180. Now this number was 200 something. This number is 180. So I can say that the least value here was nothing but 180. Okay. So with this, we come to the end of this particular session. Okay. So this session was mainly intended to make your clarity behind this factors topic very, very good.
Okay, so practice a little more of problems, at least 15 to 20 problems you practice on this particular topic. Okay, then you would be well and good. Look into the past year papers, look what kind of questions have come in the factors. Okay, so take those kinds of questions, try check yourself whether you are able to solve it or not. Okay, and if any doubts, you always get back to us. Thank you so much. Good night to all of you.